Welcome. My name is David Klein, and for the next few minutes, I'll be your guide as we look at how to integrate aquaculture into your classroom. You might be asking yourself, why aquaculture? Well, aquaculture is an art, a science, and a business, which makes it easy to include in many different subject areas. Using aquaculture in the classroom is not as new as you might think. In the late 80s and early 90s, innovative teachers recognized that aquaculture was a good way to bring new life into the career tech classroom and provide a living laboratory to explore science concepts. A push by the National Council for Agriculture Education led to the development of a core aquaculture curriculum. Experts estimate that there are now over 1,000 schools across the United States that are using aquaculture and aquaponics in the classroom. With a little subject knowledge and help from local experts, aquaculture can be incorporated into almost any subject. The most obvious connections are in biology, math, and science, but there are many others. Aquaculture in the classroom also promotes creative problem solving and collaborative learning. Students must work together to figure out the mechanical and biological systems necessary to keep their animals alive and thriving. Working with live animals helps students to learn responsibility and to take ownership and pride in their projects. Teachers often relate stories about how less academically inclined students assume leadership roles in the aquaculture classroom. Hands-on activities like lab journals and research projects also give the students a chance to develop soft skills like critical thinking and communication skills. Researching various aquaculture species and culture techniques and presenting these to the class give the students the opportunity to build these skills that may give them an edge when interviewing or competing for a job. Let's look at how some of the basic core principles that students will encounter again and again look in an aquaculture framework. The principles of osmosis and diffusion, or the movement of molecules from a region of high concentration to regions of lower concentrations, become much clearer when applied to salt and freshwater fish. Saltwater fish are constantly losing water to the environment and must continually drink water to keep their cells properly hydrated. Freshwater fish, on the other hand, are constantly gaining water from the environment and must actively process and discharge the water in the form of urine. Saltwater fish's body is not equipped for active water removal, and if you put a saltwater fish in fresh water, its cells will take too much water, which will lead to death. Photosynthesis is another important biological process that students must know and understand. Photosynthesis plays a critical role in aquaculture, providing most of the oxygen that the fish need to survive. The downside to having a lot of algae is that when it respires at night, it removes much of the oxygen present, and fish farmers must continually monitor oxygen levels and be prepared to add oxygen with aerators when necessary. The aquatic food chain plays an important role in the management of recreational fish ponds. Many people may not realize that it can take up to 1,000 pounds of algae to produce a single pound of bass. And don't forget, the food chain doesn't end at the water's edge. Biotechnology is a big buzzword in schools these days, and genetically modified organisms, or GMOs, are also a hot topic. Tilapia has become a very popular food fish, and one of the primary reasons it's seen such growth is that researchers figured out a way to grow all male fish. Wouldn't you like to know how to make a super male fish? Water chemistry and chemical cycles are critical components of aquaculture management. Students must become intimately acquainted with the nitrogen cycle in order to keep the fish healthy. As with any evolving industry, aquaculture has experienced some growing pains. If done incorrectly, there's no doubt that there may be some negative effects on the environment. Farmers today are more concerned about environmental quality and ability to operate sustainably than ever before. It's in their best interest to work in harmony with the environment, and new sustainability certification programs are being put in place to build consumer confidence. How about some math? Oftentimes, when you tell students you're going to teach them math, you can see the iron curtain close and their brains begin to shut off. But if you sneak in math as part of something that's more fun, they're much more likely to get it. They probably don't realize how much they use math every day. In working with the fish, they'll need to determine volumes, percentages, feed rates, and feed conversion ratios. And charting growth and water quality variables also provide great practice to create and analyze graphs. One of the key components that determine how many fish you can hold in a recirculating aquaculture system has to do with the surface area of the biofilter material. Ask the students how many square meters of surface area there are on a solid cube that's 1 meter per side. Then ask them what happens when you cut the cube into quarters in both directions. Can they predict how much the surface area goes up? What if you split it again? After seeing this pattern, the relationship should become obvious. In addition to math, there's plenty of physics at work in aquaculture systems. Siphons and airlifts are common methods to move water. Students can also learn about friction loss in piping, head pressure, pump curves, and more. A good experiment for students is to see how bubble size affects oxygen transfer rates. Smaller bubbles will tend to transfer oxygen more quickly than larger bubbles because there's more surface area for the transfer. But to get smaller bubbles, it requires higher pressure and therefore more energy. We must not forget that aquaculture is a business. You don't make money growing fish, you make money by selling fish at a profit. Students have the opportunity to prepare business forms that might be required to get a loan or even come up with a marketing plan. Now let's have a look at some of the subjects you might not typically relate to having an aquaculture program at your school. Aquaculture is a global industry, and the United States is really a minor player. Almost 90% of the aquaculture production comes out of Asia. Students have the opportunity to look into geography and the long history of aquaculture in those areas. The first written production manual for carp was written almost 2,500 years ago. In 475 BC, a gentleman by the name of Fan Li wrote The Classic of Fish Culture. In Egyptian tombs, there are paintings depicting the culture of tilapia. And although we think of aquaponics, the combination of aquaculture and hydroponics, is something new, the Aztec Indians were using these techniques to grow food on floating rafts more than 1,000 years ago. Aquaculture plays a major role in providing protein in developing nations. The world population recently topped 7 billion, and scientists predict that by 2050, there may be as many as 9.5 billion people on the planet. Productivity on the land is slowly increasing, but aquaculture has been growing at a rate of 8% or more for the last 25 years. And the analysts agree that aquaculture will play a major role in feeding the additional people. Growing fish and aquatic plants in school makes an excellent opportunity to learn about food safety and provides the freshest possible ingredients for culinary arts programs. How to properly select seafood is something that every consumer should learn about. Believe it or not, fish skins are being incorporated into fashion design. Leather made from the skins of tilapia, Nile perch, carp, salmon, and even sturgeon are making headlines in the fashion world. Designers are creating handbags, wallets, watch bands, and many more items. Fish and aquaculture provide a subject for ample reading in numerous books by well-known authors. Here are but a few. Cod, a biography of the fish that changed the world. 4 Fish, the future of the last wild food. The Big Thirst, the secret life and turbulent future of water. And 2 fiction-adventure novels with aquaculture-related themes by best-selling author Clive Cussler. I strongly encourage you to check them out. I know what you're thinking. Fish and aquatic critters and music? Whales and many fish make sounds to communicate. And to some scientists, that's music to their ears. But for the rest of us, here's an example of what we think of when we think of music. Gorillas in the Mix is an album made entirely of sampled animal sounds, and it includes the Fish Rap, with a number of sampled aquatic animal sounds. And there's no shortage of art projects related to fish in the aquatic environment. They can range from simple aquaria made from paper to simple paintings, to more complex paintings like this oil painting, or even paintings using watercolors. The Japanese art of gyutaku, or fish prints, make an excellent opportunity to study fish morphology. And other materials like wood, metal, and enamel also have potential. And don't forget about photography. With all the cell phones and inexpensive cameras these days, anyone can be a photographer, and aquatic subjects, including aquaculture, are abundant. So why don't all teachers use aquaculture as a teaching tool? Teachers have their hands full trying to meet state and national standards, and it will definitely require some additional teacher effort and in some cases substantial funding to get an aquaculture program started. But it doesn't have to be expensive. Few teachers have formal training in aquaculture, and many who are trained believe that they're inadequately prepared to teach this relatively new subject. Aquaculture systems don't have to be complex or expensive. This small setup can be put together with simple and available materials for less than $50, and it performs almost all of the same functions as this slightly more complex system. Aquaculture systems can range in size from very small desktop aquaria to systems made from barrels to medium-scale systems that come as a complete package, or even large-scale systems. So how can we help teachers and schools overcome the barriers to incorporating aquaculture into the curriculum? There's not a whole lot we can do to make more time for teachers. What we can do is make it easier for them to locate grant opportunities, to gather materials, and help provide them with training and knowledge that will be directly applicable in their classrooms. The number of aquaculture lesson plans, videos, webinars, and PowerPoint lectures continues to grow, and the Internet provides some excellent networking opportunities to connect the students to academia and the industry. College and university extension specialists and professors offer workshops for teachers to provide hands-on training on how to bring aquaculture and aquaponics into the classroom. One collaborative aquaculture workshop, sponsored by Auburn University, has reached its 15th anniversary and has trained over 350 teachers from around the country. Teachers learn how to design and build recirculating aquaculture systems, and they're exposed to advanced aquaculture techniques like artificial spawning, water quality, and fish health and disease management. There's nothing more satisfying than seeing the wonder on the faces of the teachers if they realize how much there is to aquaculture and how many opportunities it presents for learning and teaching. Several years ago, the Northeast Regional Center for Aquaculture put together a publication that evaluated different aquaculture curricula. And while this publication is somewhat dated, many of the curricula still exist, and now there are many more resources. One of the most popular aquaculture websites is Auburn University's ALearn site that contains over 1,500 pages of information on aquaculture, education, recreational fishing, and natural resources. It contains nearly 100 lesson plans and many videos and PowerPoint resources. In 2013, this website attracted more than 172,000 visitors from around the world. Here you can find a complete set of the National Council for Ag Education's Aquaculture Curriculum Guide. The electronic version of the Cooperative Extension System, or e-extension, has recorded a number of virtual workshops that provide information on a variety of aquaculture topics. And then there are many more great web pages and organizations dedicated to providing aquaculture information for teachers. Don't be afraid to reach out to these experts and ask for assistance and recommendations. They have the subject matter knowledge to show you how aquaculture can meet your educational needs. One of the best resources for aquaculture information is the Southern Regional Aquaculture Center. Here you can find over 300 fact sheets and a growing number of presentations on a variety of aquaculture topics from aeration to water quality. These are peer-reviewed publications that are written in easy-to-understand language by university and industry experts. They make excellent classroom resources, and some teachers have utilized them to build entire aquaculture courses. If you'd like additional information, please feel free to contact me or visit the websites listed in this publication. I hope you found this information helpful, and I hope you have a great day.